And welcome back. Now, today the postman's delivered a load of stuff. Well, in fact, he's been delivering a load of stuff over the last few days and weeks, really. So all this stuff you see here in front of me, I thought I'd just go through a few bits with you because they're all going to provide the input into future projects. And quite exciting some of them are. I just need a bit more time to get my head around some of the intricacies. So if we start with, let's have a look at this one here, for example. You may recognise this if you've dealt with this one before. Does it say what it is? No. It's well, I'm guessing actually it's either a GPS module or it's a microwave module, and I can't quite remember which one this might be. It's from Banggood, I think, this one. But anyway, that's going to provide input to a project about microwave detectors. In fact, I've got another one somewhere. Oh, well, here's another GPS module anyway. This is a GPS module. I think it says it on it. Here it is, look. U-Block's GPS module, pretty standard stuff. This is quite a nice one actually because it's got a lot of support for it. And a nice little connector there, which I think came with it. I hope I haven't lost it. Anyway, that's been sitting around in my workshop for a little while now. So I'd like to get that sort of up and running around the Christmas time really. So maybe that's a New Year video. What else? Oh yes, do you remember that I mentioned, I know, 2 or 3 videos ago now that I only had one of these potentiometers on a board, and they're great for when you're experimenting like this. You can just plug them in. And I had to use some cruddy old PCB potentiometer for the other variable resistor I wanted because I only had one. Well, I ordered another one, and here it is. And guess what? It doesn't work. No, really. I've just had this plugged in to this Arduino, well, nano expansion board, and the damn thing doesn't work. It just gives me some old funny readings. I've no idea. I haven't even had a chance to look at it. I thought, is it me? Have I plugged it in wrong? So I plugged in the original one, sprang into life straight away. So, a bit rubbish that one, isn't it, really? I have to fix that. I mean, let's face it, it's hardly complicated, is it? It's just a potentiometer with 3 pins coming out onto a plug here. So I have no idea what's wrong with that, but it's going to be pretty simple to fix, I hope. And then I'll have 2 because these are quite very useful when you're playing about with boards and things rather than having some loose dangly thing. Not for a finished project, although I said that in my last video when we used these, and I don't know, I might have had second thoughts about that actually because it's got a nice little knurled bit here which you can get nuts for. So if you were to screw this on a front panel, as you can see, the front panel would in fact not foul any of the other bits on here. The front panel will be coming up here. So this is stand off the front panel now like that. And you've got your cable already made, so maybe I'm revising my opinion of that. I don't know, we'll see. I just got to get it working first. Right, that's that one. What else have I got? Yes, this is a little kit. This is an NE. I'm going to have to wash my mouth out with soap and water afterwards, but this is an NE555 timer kit. You're thinking, do what? This sort of kit is what used to run my fridge alarm about 10 years ago, before I discovered microcontrollers. But I saw this, wherever it was, I can't remember where it was now. eBay possibly, Banggood, GearBest, who knows. AliExpress, they all blur into one after a while, don't they? But I thought, do you know what? The circuitry that I could see from the picture looked quite interesting. I thought, I wonder if they've done something so you can change the mark space ratio. Because one of the downsides of an NE555 timer chip is that the mark space ratio was limited. I think it was to about a 50% mark space ratio, unless you did something really fancy with a couple of diodes and things that all got a bit fiddly then. So I thought, well, I think this was like £1.50 or something. I thought, you know what, I'm going to buy it and just have a look, see if they've improved. So that's just a bit of, well, nonsense really, but I'll still build it and show you. Perhaps show you on the scope what it can do. In fact, why the Arduino with the PWM library is so much better than this. Okay, that's that. What's this one? Now this one. Now you might, if you're into this sort of thing, you'll immediately recognise that this sort of snaking trace is in fact an aerial. So if that's an aerial, what is this? What does it actually do? Well, it's a microwave transceiver, I suppose you call it. Now, I'm sure you've seen PIR modules, those little white blobs that can detect heat, I suppose, human heat walking across them or towards them, and they're fine, they do their job quite well. But this is a microwave one. Now this will go through doors, it says. So I'm hoping I can get this all put together. It might need some sort of amplification circuit, I'm not sure yet. That's the trouble when you buy these things on spec, isn't it? And you figure out what the difficulty is. But there we are, we have the technology, and if it does need an amplifier, no problem, because I've bought somewhere a whole stack. Ah yes, here we are, a whole stack. Look, I think this is 99p for however many's in this bag, at least 20, isn't it? BC547 transistors, really useful, use them all the time, decent gain. I think I used these in the Christmas tree audio amp project, to amplify the microphone, and they did a damn good job. So I thought, yeah, I'm going to get a few more of these because down to my last one or two. So that got bought. So if we need to amplify the signal from here, the output signal, these will come into play, because we're not talking microwave amplification. That's all done on here. We're talking the actual output amplification available at these pins, well, wherever they are in there. So it might need a bit of amplification before it hits an Arduino. Not sure yet. We'll look at that. That's microwave. What's this one? Well, I think we should dig that one out. It looks like there's an LED in there and something. Let me dig that one out. I haven't even opened it. Look, without slicing the finger off. See if we can get it out. Right. Here we are. So what this is, we'll have a look on the internet in a minute where I bought it from. This is in fact a slightly bent, as you can see, a slightly bent, there we are, pulse detector. The idea being that this thing here is the detector. You stick your finger underneath. I've absolutely no idea, like that perhaps. Looks reasonable, I suppose, doesn't it? Like that. This transmits the light, although in that case I would have thought that would have been bent down a bit more, quite frankly, so it should go like that. But anyway, we'll see. And it's supposed to detect your pulse. No idea how it does it, but can't be that difficult because they're selling like hot cakes from our Far Eastern friends, so that would be a nice little thing to do, wouldn't it? If that does work, actually, you could make it in a little box with a battery, an 18650 or something. Well, quite frankly, even a couple of AAs would probably work, wouldn't it? And then just on-off switch and take your pulse at regular intervals. Sounds like a winner to me. Anyway, that'd be interesting to do. This has got nothing to do with Arduinos. It's got nothing to do with, well, microprocessors really, although of course there obviously is one in here to fit into this big slot here. But what it is looks a very nice LED clock with some circular LEDs around the edge. In fact, we'll go over to the browser window right now and just have a look at a few of those, because I only bought this because I thought that looks really flash. I'd like to build that because I'd like a clock on my desk here in front of me somewhere, and I thought if I'm going to get a clock I might as well get one that's sort of vaguely electronic based, and this one most certainly is. So let's go over to the internet and see where I bought it from. Oh, and there we are, look, right in front of me it is. So let's look at this one first. I'm going to go to the main monitor actually, so we can get a couple of windows up at a time. So let me just click a couple of buttons and, oh, okay, we're on the pulse meter first. So the pulse meter was this one here. See that? So that's exactly what it looks like in the picture. Fine, and I've got two pieces for, would you believe, 99p. I mean, that's why I bought it. I thought, well, for that price, it's worth a punt, isn't it? And just see what it can do. I'm hoping there's some information somewhere on the internet that will let me just connect this up really easy. It's got three little connectors on it, as it shows you there. Probably plus, minus, and signal. You'd think it would be an analog signal, wouldn't you, being a pulse meter, but perhaps it's digital. Well, we shall see. Anyway, that's there. So that's two pieces, 99p. That's a winner. Right, now this is the clock module. That's this thing here. And as you can see, it's got this digital clock bit in the middle. Let me just kill that. Right, so you've got the digital clock in the middle, and then this outer ring that builds up and then destroys itself. So I mean, they go out, so they come on one by one all the way out, and then go off as the seconds tick by. And I just thought, it just sounds like an interesting thing to do. Of course, at the back of my mind, I thought, is there something we can do with the LEDs with an Arduino, a Nano or something, and perhaps do something with these LEDs, make them brighter or dimmer depending on the time of day? We shall see. Anyway, that was only £4.73. I did mention in one of my videos that the first thing I truly built as a sort of a young teenager was an alarm clock. And at the time it cost £16, which was more than a week's wages in those days. Yes, I know, I was born in the age of the pony and trap and pre-electricity and all that. But it was £16. It was a wonderful LED clock. Worked beautifully for years and years and years, but it was 16 quid at the time, so that's more than a week's worth of wages. And here we are with this one, which is £4.73, which is about what? Just over half an hour's work on minimum wage. I mean, that's why I bought it again, £4.73. I thought, yep, I'm going to put that together and just see how well it looks in real life. So right, that's that one. What else have I got? I don't know how this thing snuck in here. That's not Arduino based, is it? We'll quietly forget about that one. Sorry? Oh, you want to know about it? Okay, well this is an Orange Pi. Now we've all heard of Raspberry Pi, but they're too expensive for me, and more to the point, I don't need a full-blown computer to, you know, turn fridge alarms off or cat runs or whatever. But this is an Orange Pi, which is an open source variant, I suppose, of Raspberry Pi. They're not totally compatible, but pretty close. And this thing in here, I haven't even unopened it yet. I'm not going to yet either. This is what's known as an Orange Pi Lite, and it was about 10 quid, maybe a couple of quid more actually, because I got the wireless version. See the aerial in there and the wire. So this is a Wi-Fi version. It's got two USB ports on it. It's got an HDMI port, a micro USB to power it, an SD card socket, and I thought for 13 quid it's basically a computer on a board, COB, I think that's what they call it, plus, oh yeah, plus of course, it's, you can see, just see through the plastic here, this row of header pins, which is a sort of equivalent to our GPIO pins on the Arduino. So I thought that could be something useful just for me to look at and then to share with you, of course. So for 13 quid, I'll put my hand in my pocket. I mean, it does sound quite a lot compared to a Nano at 2 quid, doesn't it? But that could be interesting, but that's some way off, probably in the new year for that one. So depending on when you're watching this video, that may or may not be released yet. Right, now on this desk here, you'll also see this ring of LEDs, which is commonly known as a NeoPixel, or at least SparkFun call it that, but there's a million things out there on the internet. And I thought, now that would be something useful to look into, because as you can see just about here, let me just turn them down. We'll go through the code on this. There's 3 pins on here. There we are. You can just about see the 3 pins. Well, there's 3 wires. Yeah, I know. So you're probably thinking, okay, so you've got 12 LEDs on this ring. How are you controlling 12 LEDs with just 3 wires? And believe me, it's a miracle of modern science. These LEDs, which are full RGB LEDs, each one of them, right? They all get controlled by a single serial wire. Now the actual pulses that come down the serial wire are quite complex, and I don't think we're going to be delving into exactly how we deliver that pulse, because I'm using a library in this little demo code, and as you can see, the demo code consists of this NeoPixel ring and this pot, plus of course the Arduino at the back. That's it. So there's not many components needed just to prove that this works. And all the code does is say display the first 4 in green and the next 4 in yellow and the next 4 in red. And that is amazing, isn't it? That's it. That's all it does at the moment, just to prove it works. So if you're thinking, hey, this sounds like something, and these NeoPixels, by the way, these are in fact a particular type of LED. These LEDs are in fact a WS2812B, which is very common these days, very common indeed. They're sort of a slightly improved version of the 2812, because they've only got 4 pins on each of them. So you've got plus, minus, data in, data out. But we'll come on to the intricacies of these, because I want to build this into a proper project. And the project is a security project. You might even have one in your house already. I certainly have. but it's something that could be run any time of year. It could save people breaking into your house. So I'm hoping I've piqued your interest. And the fact that they're RGB, well, you might be able to guess what it is, but let's have a look how this bit works. And by using that library so simply as well. Right, here's the code, and this is all the code. This is the complete sketch to prove that this works, which I've adapted from, I don't know, there was a sketch either on SparkFun or somewhere. I'll put a proper attribution to the sketch that I use when we do the final project. But this is just sort of a little taster, because if you're thinking, hey, I'd like to do that, then this is a chance to order something. So we're using this library at the top here, and it's called FastLED. I'll put a link where that can be found as well. It's a very good library from what I've read so far. You just tell it how many LEDs you got, the data pin that it's coming out of, so it's coming out of number 2 in this case. This just sets a few things up. That's the object that creates, that controls the LEDs. Here's where we set it up with the number of LEDs, the pin that the data's coming out of, and so forth. We're reading in the value then from the pot down A0, which aka pin 14, and then mapping that value to the number of LEDs. Now, when I try to map this here to 1023, which is what the full range of this pot should be, the last LED on here started to flicker, and I thought, what's going on? So that's why I put this serial print in here. And what happened was, even at full rotation all the way around, this was jumping from 1023 to 102 to 1019, 1021, 1022, 1019. It kept jumping backwards and forwards. So I thought, right, we'll just kill that on the head. We'll just say, look, anything from above 1,000 will be treated as 1,000. So we're mapping 0 to 1,000 to 0 and the number of LEDs by this little map thing here, which I've covered in previous videos. Just stops you having to think about how to do it, really, dividing one into the other. Too much work. Arduino give you this for free, don't they? And then what this says is clear the previous LED state and display the LEDs. Now, what this bit here I've had to change because I've only got 12. The original code had something like 21 or something. So I've said basically if it's less than 4, so 0, 1, 2, 3, make it green. Greater than or equal to 4 but less than 8, make it orange, and greater than 8, make it red. So that's exactly what you're looking at down here. So the last 4 are red, then it goes to, well, it looks more amber in real life. Let me just bring the workbench up. So this looks more amber in real life. I think on the camera it looks a little bit more yellowy. But let's face it, it's RGB. You can make it any color you want. Any individual one of these can be any color you want. Okay. So, and then it just sets the brightness. We're setting it to 50. You can change that as well. Not for each individual LED though. Not sure how we're going to do that. So if you wanted one super bright and then one super dim, not quite sure how to do that yet, but I certainly will by the time we do our project, because it's important that we know that. And then we just show the LEDs. Now, when I looked at a library, not this one here, I was looking around on the internet for some sort of library, how we might control this. It's, well, I wouldn't say complex, but the timing is absolutely critical. Now, from what I can remember of the data sheet, each on bit on here has to be exactly 800 microseconds long, and each off bit has to be 400 microseconds long, with a variance of something like 150 nanoseconds. Now that is pretty tight. You're talking, you know, 1 or 2 operations there on the clock. And I thought, you know what, is this channel really about delving into the intricacies of, you know, 800 and 400 microsecond clock pulses? Not really. Even if we went down that route and decided to write the basis of our own library, what would it prove at the end of the day? It would prove that we're pretty rubbish at creating libraries, quite frankly, because that's this one here for a start that's mature, it's been corrected, it caters for any number of LEDs, it does NeoPixels and others. I mentioned the 3812, 3812B, but there's loads of others out there. So basically we're not going to go there. We're going to be consumers of this FastLED library so that we can build something out of this, not just a pretty little pattern like this, I mean, these LEDs could be jumping all over the place, you know, making sort of patterns. I'm just doing it on here to build them up and just to show you really. But this is going to be the basis of a very simple project. It will require a nano, or Uno, whatever you want to choose, but that's a couple of quid. This was, I don't know, I think it was a couple of quid. I'll find out in a minute. Well, we won't need a pot. We will need a light dependent resistor, which is, I think you get about a zillion for £1 or something these days. And what else do you need? Well, you need a power supply. Plug in, you know, 5 volt possibly. Yeah, 5 volt would be plenty. In fact, I was going to use a 9, but I think, do you know what? This runs on 5. And we can't power all the LEDs that we might want from the Arduino. Actually, in this case, we can because we've only got 12. But say you had a whole bank of them, you can get them huge these days, as big as this mat, probably even bigger. And that would, of course, be far too much current for poor little the regulator on here to do. So you'd have to supply it separately. So I think, well, in that case, we might as well just use a phone charger. So a 1 amp or 2 amp phone charger type connection, USB, would be fine. And on here, we can run it directly from the Nano as well. So we can plug in either a 9 volt here or 5 volt, and it will work just fine. So that's for a future project. I've got to work out how to do some stuff on here first. So I've got to read up about the library, and then we can get busy. So it's a security type project. You might be able to guess what it is. Well, if you do guess what it is, if you think you've got a guess, why don't you put a comment down below and see if you're right. I'll just tell you yes or no. Well, no, I won't tell you yes because that will get the game away, won't it? But I'll tell you no if it's not. All right, maybe. Perhaps it'll be a double bluff. Who can tell? All right, that's it then. So some interesting stuff coming up. Quite a bit, funny enough, with LEDs, isn't it? All these things coming across, but then LEDs are quite pretty, aren't they, to use, and people like them. And I'm really looking forward to this microwave sensor. See if it really can see through doors. Oh, the other thing is, unlike a PIR sensor where you have to point it at things, this is a 360 degree coverage with no gaps. It says no gaps. So it's like, if you can imagine this transmitting, it's like it's in the middle of a huge big bubble and it can detect from anywhere. We'll see. We'll see. All right. That's it then. I'll be getting my pulse meter working first because the excitement level's certainly gone up a bit. Okay, short little video this time, as I say, because at the time of this going out, I'm actually on holiday. Not to worry, I'll be back soon. And if you're looking at this any time after Christmas 2016, I had a great holiday. Thanks very much. And yes, I'll tell you all about it when I get back. But I've already come back, forget it. Okay, thanks very much. See you in the next video. I hope you're finding these videos useful and interesting. Please leave comments down below, subscribe, share, and give me a thumbs up. Thanks for watching. See you in the next video.